Hey guys, thanks for tuning in to another video notes where we will be reviewing the transformations on a quadratic function and graphing the transformations by hand. Now before we start, did you know that Coca-Cola is actually green before they add the food coloring? Yeah, Coca-Cola is green. Anyway, on another note, let's talk about this first function here. Notice we can see right away that the parent function is x squared. So we have a quadratic function. So when you apply a negative, we have a reflection. Across or over the x-axis. So rather than opening up as the parent does, the parabola opens up. In this case, the negative makes the parabola open down. Okay, and here we go. We have the parentheses. We have some constant here, h. And this constant, whatever this number is going to be affecting the x value. So in this case, this function would be moving h units to the left. So translated, h units to the left. So remember that when it's adding, it's to the left. And on the second one, we have another horizontal translation here. So we have a translation. So this one is translated h units to the right. That would be subtraction. Okay, and as a review, also here, notice that the k is not in a grouping symbol with the x, so this k, this value is going to be affecting y. Okay, so k, this one's going to be translated k units up. And k translated k units down. Remember, you can pause the video at any time if I go too fast and review. Okay, so on number 6, we have the y values. Remember that x squared represents the y values. That's the function being multiplied by a. So if a is greater than 1, then vertical stretch. Okay? If a is greater than 0 but less than 1, okay, then vertical compression. So a stretch, remember, would mean that the graph would appear to be narrower than the parent. And a vertical compression would look like the graph would appear to be wider than the parent. Now the parent has an a value of 1. X squared. Notice that the value in front of the x squared is a 1. 1 times x squared. Okay, so on number 7, this is one that we did not get to yesterday or the day before. is where we have actually have to factor a number out. So the best way to explain this is that if you have something like this, okay? So what we have to do is when there's a value in front of the x like this, you have to factor it out of both terms. So what we need to do is think of what number that goes into 2 and 8 evenly. And so 2 goes into 8 and 2 evenly. So we're going to factor a 2 out. And that gives us, so 2 goes into 2 one time, so that gives us 1x. 2 goes into 8 4 times. Okay, so when there's a value other than 1 here, you have to factor it out in order to see the horizontal translation. So in this case, this graph is moving 4 units to the left, translated 4 units to the left. I'll write that here. Four units left. And something new. Notice we have a 2 that's inside the parentheses. So remember that means we're going to have a horizontal effect. So now everything's the opposite with horizontal. So that means that up here, remember when A was greater than 1, we had a vertical stretch. Okay? So when this number right here, we're going to call B. So if B is greater than 1, then horizontal compression. Remember, opposite. And then if B, in this case, we have a 2, which is greater than 1, so this would be a horizontal compression. Okay, the other instance would be that if the B value is, I made a mistake up here. I needed to make that greater than. If A is greater than 0. Sorry about that. So if B is greater than 0 and less than 1, then we're going to have a horizontal stretch. Running out of room. So we'll be practicing that a lot more later. Let's take a look at number 8. Now it says we're not going to use a calculator. So what we need to do here is we need to start at the parent. So remember the parent, number 1, it's quadratic. See the 2? So if I take the parent, and I'm going to go ahead and use pencil. So the parent goes through 0, 0. Okay, so if I plug a 1 in, 1 squared is 1, so 1, 1. If I plug 2 in for x, 2 squared is 4, 2, 4. Plug a 3 in, 3 squared is 9, so 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and it's symmetrical, so on the other side it's going to be the same. So here's our parent. And we're going to use this transformation. So when you transform, we're going to use the translation first. So we have 3 units translated, 3 units to the right. So we're going to go 3 right. And it's translated 1 unit up. Okay, we do not use a calculator for this. We can do this by hand. So we're going to go 3 units to the right and 1 up. So taking that vertex point, 3 right, 1, 2, 3, and 1 up. So the vertex went from here to here. Next, we apply the negative, and we know that a negative reflects it over the x-axis. So this parent is not going to be opening up, but it's going to be opening down. So from here, we're going to go over 1 unit and down 1. Whereas on the parent, we went 1 unit up 1. So over 2, 2 squared is 4. 1, 2, 3. 3 squared is 9. And it's symmetrical, so it's going to be the same on the other side. Now after you graph it by hand, hopefully you're using a pencil, you can go ahead and check on your calculator, see if you got it right. So I'll describe the transformations. I kind of already did that. Okay, but remember, I want you to use proper vocabulary. Translated 3 units right. Translated 1 unit up. Reflected over the x-axis. Okay, let's take a look at this one. So again, we start with the parent. So I'm going to put the parent in real quick. You don't have to, but it might be helpful. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, again, do the translations first. 4 left, 2 down. So I'm going to go to that vertex. 4 left, 1, 2, 3, 4, and 2 down. 1, 2. So there's my new point. Okay. Next thing we're going to do is we're going to apply this vertical stretch of 2. So remember on the parent, we went over 1, up 1. Okay, so we're going to multiply that y value by 2. So over 1, up 2. On the parent, it's over 2, up 4. So 4 times 2 is 8. So over 2, up 8. And it's symmetrical. So we can just go up and over 1 to get that symmetrical point. Up to that point and over 2. And here is our vertical stretch. And then, of course, write your transformations in here. Please have this done. I told you what they are. All you have to do is write them in. Okay, finally, last but not least, given the interval of negative infinity to infinity, what is the maximum or minimum? So when looking at a graph, a maximum is going to be found at the highest point possible. So the maximum here is going to be, and it's going to be the y value. So 1, 2, 3. So our maximum value is y equals 3. That's our maximum value. Now this one has a minimum. So in this case, our minimum value here is going to be -1, because that's how far down it goes. That's the lowest point. So y equals -1. Okay, we'll stop right there. I'll see you guys in class.